This is chapter 2 in our CAD drafting program, the one that you see right here. We've already started working with Introduction to Design and Drafting. For this class, I finished the chapter 1 and now we are going to chapter 2. So let's see what we have in all the 10 chapters. The first chapter was Worldwide Graphic Language for Design, which is already done, and the second one is the one that we are going to do today. So the name of this chapter, the topic name, is Technical Sketching and Geometric Construction. Now let's see what the objectives are for this chapter. What we are going to learn is how to define a vertex, edge, plane, surface, and a solid. 4 different types of surfaces, identify solids, draw points, lines, angles, arcs, circles, ellipses. So there's going to be a lot of drawing that I would be doing over here in this class today. Then we are going to draw some octagons and hexagons. We are going to learn how to bisect a line and work with angles. Drawing a lot of arcs using the tangent method. We're going to see the different line types and line weights, and we are going to sketch symmetrical drawings using the grid. And lastly, we are going to have some questions and answers. Okay, now let's get on with our work. So again, I have my objectives listed over here as well. Let's begin with the first objective, which is defining a vertex, edge, plane, surface, and a solid. So what I would be doing here is making a simple cube. Okay. Now this is a 3-dimensional object. And if I were to point the vertices, it would be these: 1, 2, 3, 4, 5, 6, 7. Okay, and these are the ones that I see right now. There are vertices which are behind that I don't see. So to define a vertex of a solid is formed when 3 or more surfaces intersect. Okay, so in this case, this is one surface, this is surface number 2, and this is surface number 3, and the vertex that we got is right there. Okay, so that defines the vertex. The plural of a single vertex is vertices. Okay, and a single one is called vertex. So now let's see what an edge is. So the edge of a solid is formed when 2 surfaces intersect. In this case, we have surface number 1 and surface number 2. So the edge that is formed when these 2 surfaces intersect is that one. So this is called as an edge. Correct? So we would define again the edge as when 2 surfaces intersect, what we get is an edge. Okay? So that was edge. Now let's look into what a plane is. Now a plane is when, in this example, if I were to highlight the plane, an example would be this surface, or it could even be this, or number 1. Now what a plane, if you want to define it, what is a plane, is something that comprises of more than 1, 2, and 3 edges, or even something that has a minimum, I would say, of 3 vertices. So if I have 1, 2, and 3 vertices, if I would join these, what I would get is a plane. Correct? So anything more than 3 vertices would give me a plane. And a plane is also a 2-dimensional figure. It's not 3-dimensional. Okay, so this could be considered as a plane. That could be considered as a plane. Even this surface could be considered as a plane, as far as they are lying on the same surface. Okay, now let's go to what a surface is. Now surface is something like the plane. Now the surface can be flat, or the surface could be irregular. For example, the earth has a surface. Okay, it has mountains and it has valleys and it has flatlands, but in all you would define the earth as something that has a surface, right? So in this case, this area could be a surface. No? This highlight that I just did could be a surface. Surface could be flat, the surface could be undulated, the surface could be going up and down. Okay? And last one is what is a solid. Now again, anything that has 3 dimensions is a solid. The example on the screen is this whole cube. This whole cube is a solid. Why? Because it is 3 dimension. If I were to draw just this is not a cube, right? So this is just a plane which has just one surface, which is 2 dimension. Now this one, on the other hand, would be a solid. Let's see some more examples of solids. So another example I would draw is something that looks like this. Now what do you think this is? Now this is a solid cylinder. Now more examples could be if I were to draw a pyramid. Okay, now what other examples could we draw? We already have the cube that I did there a minute ago. Again, this is a solid. Then we could have a sphere, right? Even though it looks like a flat circle, but if I would shade it, then that would look like a sphere, right? Something like that. I hope you get the idea, right? So that's the sphere. I could even have a cone. A cone would look something like that and like this. Have you seen a cone? That's exactly how it looks like. A 3-dimensional cone. Now let's see what are the 4 different types of surfaces. So I'm going to get rid of all this and let's draw 4 different surfaces. The first one being planar, P-L-A-N-A-R surface. The second one would be a single curved surface. Third one would be a double curve surface. And the fourth one is a warped surface. Now if we were to draw a planar surface, just going to draw simple geometric figure. which is a 3D, correct? So this surface on the top is what is called a planar surface. Why? Because it's made up of a plane and it's flat. Even this surface would be a planar surface, this surface would be a planar surface, this surface would be a planar surface as well. Now let's try to get a curved surface, a single curved surface. Now a single curved surface, an example would be just a cylinder. Now what you see in here is only one surface that is curved. What about the top surface and the bottom surface? What are these? These would be called what? Planar surfaces. Why? Because they are flat. Now let's see the third one, which is the double curved surface. Now this example for that would be a donut. Pretty sure you've eaten a donut, right? So a donut has the surface, both of them are curved. So that would be called as a double curved surface. Now let's see the last surface. The last one would be a warped surface. Now this surface again could be, an example could be the surface of the earth. Okay, this side I'm going to make it go up a little. Okay, and if I were to draw some lines that would show that this surface is not flat. So this surface would be called as a warped surface. So I hope you understood all the four different types of surfaces that we had. Now let's go to the next topic, which is first of all drawing lines, points, angle lines, arcs, circles, and ellipses. Okay, so first we have to understand what a point is used to basically represent a location. Okay, location where? Location on the planet, location on the surface of the earth. For example, is if I am standing somewhere, I have a location on the surface of the earth, and these locations are given how? Are given with respect to the coordinates. Remember we had the x, y, and z coordinate. So if I tell someone what my coordinates are, then they can find me without any problems, right? Because my point is the only point on this whole planet where I could sit if I were to give them the x, y, and the z coordinates. Now, why is points necessary when it comes for us to draw? Is because, for example, if you were drawing a house. Now, the house is located in a certain city, in a certain neighborhood, in a certain location, right? So I have to plot the house onto the exact same location, geographic location where it's located in this world. So that's why I would give the points for the location of my plot, or I would say the site. Maybe my site looks something like this, and this is comprised of so many different points, and every point is given an x, y, and z axis, right? So it's basically given the coordinates. So if someone were to find my plot, all they had to do is make sure what the coordinates were, and it would be easy for me to show where my location was. Okay, so at least we understood what a point is, right? Now if I were to draw something, again it always starts with a point and probably end on a point. So, and if I connected 2 points, what would I get? I would get a line, right? So a line has to have a minimum of 2 points, correct? Now let's see, how is the point represented in the different drawing. When two lines meet, where do they meet? They meet at a point. Okay, so one of the symbols for denoting a point is going to be something that looks just like that. Now let's see what a line is. Okay, now that we understood what a point in space is, now let's see what a line is. So a line is used in drawing to represent the edge of a solid. A straight line is the shortest distance between 2 points and is commonly referred to as a line. So if I were to draw a line, I would have 2 points, and if I were to join these 2 points, what would I get is a line. Now this is a point, this is a point. Okay, now there are so many different types of lines that are used in our drawing. One of the lines that is called as a horizontal line, and where it goes is just like that. Okay, 0 degrees, right? Second is vertical line, and the vertical will go how? It's gonna go straight down, right? Like 90 degrees. Then there is a line. If I would draw this line, now this line has indefinite length. Why? Because we don't know where it ends, we don't know where it started. But if I were to draw this line and give an end here and end here, this one would be called as a definite line, right? Because it starts at a point, ends at another point. You could even call this as a segment. Okay, now let's look more into lines. If I wanted to draw a perpendicular line to this vertical line, how would I do that? All I have to do is make a line going straight up and hitting my vertical line. So this angle would be how much? 90 degrees. So what I have over here is perpendicular lines. Correct? This is line 1 and this is line 2. Now what are more different things about line? Now let's see some more. What if I wanted to draw parallel lines? I have a line that goes like this. If I were to draw a parallel line, I have to make sure it's going parallel to the previous lines. Now if you see the grid, now these grids are parallel lines as well. At the same time, they are even what? They're even going 90 degrees, right? They're even perpendicular to each other. Okay, so we saw what is a horizontal line, what is a vertical line, what is a straight line, what is perpendicular lines, and what is parallel lines. If I were to denote the symbol for the parallel lines, I would denote it as like that, right? If I were to denote a symbol for a perpendicular line, I would denote it just like that. So if this was line A, this was line B, then I can say line A is parallel to line B. Okay? And line D is perpendicular to line C, B, and A. Alright, so let's go to looking into more angles. The next thing is just angles. So when I draw two lines that are perpendicular to each other, again this is 90 degrees, right? So that is the angle between these two lines. If I were to draw at an angle of that, and if I measure it with my protractor, that comes to an angle of 45, correct? Now this is line A, this is line B, and this is C. So I would denote it as angle C is equal to 45 degrees. Okay, this was D, and I would say angle D is equal to 45 degrees. So this is how I would show an angle. An angle always have to have two lines that are intersecting at a certain point, just like the ones that you see in the picture. Get it? Now let's look into some more geometric shapes. Now if I were to draw a circle, now a circle has a couple different things that we need to know. Okay, one of the things it has is a center, and the second thing it would have is a diameter. Now if I were to draw a circle, I have to have a center point, right? This is where I would put my pointed edge of my compass and then draw the circle with respect to whatever the diameter is. The symbol for the diameter is just that, and you just slash it out. And what is a diameter? A diameter is a distance that is going from one end of the circle to the center to the other end. And so the diameter of this would be maybe 5.0 inches. Got it? If I were to show a radius in this circle, a radius is denoted by a capital R, is usually associated with arcs, but a radius is equal to half the diameter. So if I were to draw it from the center till one end, so this is my radius. And how much would my radius be? Radius is equal to half of 5, is equal to 2.5. Okay, so if I were to use a compass to draw my circle, even though I know the diameter, I have to half the diameter so that I can put one pointed edge over here and the pencil edge over here, and then draw my circle. Okay, I cannot just start with the diameter, right? If I just start with the diameter, what am I gonna get? I'm gonna get a double-sized circle, which is obviously I don't want it. Okay, so you would have to do that little calculation where while drawing it, you will have to half the diameter for the radius and then draw your circle. Now, what would be called as an arc? An arc is like a circle, but obviously it's not a complete circle. So it does have a center point, and it's just that much. Okay, it does have a center point, it does have this, and what is this called? Again, this is called the radius. Okay, it has a start, it has a end, if you were to specify it, right? Or else mainly a radius is associated with a mainly an arc is associated with a radius. Okay, now if I were to have an arc over here, I could just draw it just like that, and that part would be an arc. Okay, not the whole circle. And again, it's important to remember arc is always associated with a radius of, whatever number you want, right? 2.0. So we got the arcs. Now the next thing we would do is look into what an ellipse is. An ellipse is something that has two radiuses, and is symmetrical along its vertical and horizontal. Okay, it looks more like a circle but stretched. So if I were to see what an ellipse would be in a 3D object, for example, this is my cylinder, which is in 3D, and if I were to cut it somewhere, right there, okay, how would I draw the ellipse? Okay, so that section which I cut would look something like that, right? My cylinder would look something like this. So to draw this surface, I would have to use two different radiuses. From the center, one radius would be this, and the second radius would be from the center going this way, right? So one radius, second radius. Okay, so if I were to draw an ellipse onto our grid, I would draw it just like that. 1 and 2. Okay, we'll be doing an example of an ellipse. Okay, so don't worry about that. So this is radius 1, and this distance is the vertical distance, is radius 2. Okay, so now that we understood what are points, lines, angle lines, arcs, circles, and ellipses, let's go and do some drawing. Okay, I'm going to go to the next sheet. I will skip this one right now. First, let me do the drawing and then we'll go back there. Now, on the right side, you see so many assignments that we are going to do, starting with sketching a circle in the square below. Now this drawing is already complete, so the way I'm going to show you is just trace on top, and you could follow the steps as to how we are going to do it. Now let me just go ahead and zoom our drawing so I have a little bit more space of working on it. Maybe 150 should be good. Okay, so now what we are given is just a square, and we are supposed to put in the circle right there. So the first thing what I need to do is find the center of my square. So if I would use my ruler and measure it, or even approximately, I could just draw where the center of my square is. Next thing I could even do is I could use a ruler and just cross those lines. So once I get that, what I have got is the center point of my circle. Now what I would do next is use a compass. Now a compass is something that looks like that, right? I'm pretty sure I showed you what a compass looks like. On one side you have a pointed edge, and the other side you have a pencil edge. Okay, this is pointed edge. So to draw the circle, what you usually do is put the pointed edge on the center, put the pencil edge on one of the corners, and I could just go ahead and complete my circle by turning my compass. Okay, this is how I would do with some tools. But what if I didn't have any tools? Okay, what if I were just to sketch my circle? I would have to approximately again find the centers of the square and freehand my circle by just making arcs. That's arc number 1, that's arc number 2, arc number 3, and arc number 4. See, that didn't come out perfect, so I could erase it and then go back and fix it. Even that didn't come out right. So that would be sketching a circle when I'm given a square. Now the next example is sketch a circle using the center lines. It is similar to the first one. Only thing we don't have is the square. Okay, so all I'm given is the center cross mark. So obviously I have 1 point, 2 point, 3 point, and 4 points. Now if I were to sketch the circle by hand, I would just draw my arcs. Arc number 1, arc number 2, arc number 3, and arc number 4 to close the circle. Now if I were to draw it using my compass, I would put the pointed edge right in the center, put the pencil edge on any one of these, 1, 2, 3, or 4, and then turn my compass to finish drawing my circle. Got it? So this is how you would do these two basic examples for drawing a circle. Now what if I had to draw a circle onto this? Now what you see onto the screen is what? Is a cube, right? And the cube is 3D, and it's at a certain angle because it is an isometric view. Now we'll get to isometric view later on in a couple chapters, so don't worry about that. But when I am supposed to draw the cube in isometric view, my cube is at certain angles, right? So if these were the angles, they are 120 degrees. So I have to make sure that when I put in a circle onto this three-dimensional cube, if I were to draw a circle that looks like that, my circle would look something like this. This circle would look something like that and like that, which are perfectly round circles, but obviously that doesn't look right. So in this case, if I were to draw it, how would I draw my ellipses? Now the first couple things I need to know about ellipses is they have two different radiuses. So if I were to use my compass and do that, then I would do it that way. But this is just a sketch exercise, so I'm going to just sketch it out. Now how would I sketch it out? First thing is, all I'm given is this surface, right? And I have to find the center, 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 and center, just like I did right here. Once I'm done with the center, I'm going to go nice and slow and finish my 4 arcs, right? So I'm going to put my hand, now again I'm doing this freehand, right? So I'm going to make 1 arc, which is a little bigger, second arc, which is more steep and more smaller, third arc, which is like our arc 1, and the last arc, which is like our arc 3, which is more steep. So now you would get this again with certain practice, okay? But obviously your circle on the cube is not going to look like a circle if we were working in 3D view. Okay, now let's try this on the second one. I have the center of the surface, 1, 2, 3, and 4. And all I have to do is work with my arcs. Now this arc is going to be the steep and the smaller one. If I would want to do the second one at the same time, opposite side, steep and smaller one. Now this one is wide and bigger and touches the same point. Wide and bigger and touches the same point. So this is how you would practice, or you would make an ellipse onto a 3D object. Okay, but in reality, is this supposed to be an ellipse, or is it just a view? Now this is just a view. In reality, if I were to draw the top of my cube right here, which is just the one surface, it would look exactly like a perfect circle. Okay, but again, we are viewing it in 3D. That's why it wouldn't look like a perfect circle over here, here, or here. Okay, so I hope you followed that. Now let's get to the next one. Now the next exercise is for bisecting the triangle. Now basically what we have to do here is we are given just this triangle, and in our case the triangle has equal sides. If this is 5, this is 5, and this is 5, if I measure it, right? And this would be called as what? Equilateral triangle. That is when all the three sides are the same. Okay? And the second type of a triangle would be called as what? If only two sides are the similar length, then this would be called as a isosceles triangle. And if none of the sides are similar, then this triangle is called as the scalene triangle. Okay, so you understood different types of triangles over here as well. Now let's see how would we bisect the triangle. Now to bisect the triangle, first thing we have to remember how I bisected just my two lines. If I have line A, line B, both of them are at an angle of 90 degrees. If I were to bisect it, bisect meaning if I were to make it exact half, so I would have to bisect somewhere here, and this would be how much? 45 degrees, right? Why? Because the total is 90 degrees. So bisecting would give me an angle of 45 degrees for that particular example. Now again, there is a way of bisecting it rather than just eyeballing it, right? So how would I do that if I were to bisect this angle? So the first thing I would do is take my compass, which is right here, and put the pointed edge of my compass right there, and take the distance on my compass, which is a little more than half of the distance of CA, maybe from here till here. Okay, and then I'm just going to swing and arc going to there. At the same time I can do it over here. Okay, I could draw the whole thing, but I just stop somewhere in the middle, and then I put it on the side C and B as well. So now I did that. Now the next thing I would need to do is do the same thing, but now I found point D and E, right? So I'm going to put my pointed edge on D and swing another arc, which is again a certain distance. Again, it's approximate. You don't need to worry about the distance. Just make sure it's not too small. So I swing another arc going like this. Now I take my compass, put the pointer edge on E and the pencil edge, which is the same distance as the one we used for that, and then swing another arc. So now what we got over here is an intersection. And what I would do is just draw a line going from C to the intersection which we just found. And what we've already done is bisected the 90 degrees to 45 degrees already. So when I'm doing my triangle, I would do the same exact way, but I would be doing this on what? I would be doing it on 3 different sides, right? So it's thrice the work, but the procedure still remains exactly the same. So let's try doing that. I'm going to go zoom in into my picture and I'm just going to trace it right there. So what I'm given is this. This is the only thing I'm given in my problem, right? And I have to bisect it into 3, right? It says bisect each leg of the triangle. So what I would be doing on this one is bisect the triangle. So basically like bisecting the segments that we did before, pretty much the same. Only thing is, this is an equilateral triangle, as in all the sides are the same size. So it's okay if I bisect it using just bisecting the segment. But if it weren't an equilateral triangle, instead of just doing that, I would have to even bisect it like this and then go like this, go to the second one, then make that, and the third one, right? But because if it's an equilateral triangle, I could just bisect it in one place and then make a line going straight to the vertex, right? But if this vertex was off, I wouldn't be able to do that. So in that case, I would have to bisect it like that and continue going all the way down up till here. Same thing on this side. I would go all the way here and all the way up till here till I get 1 and 2 points, and then make a line joining both the intersections. So let's do that right now. I'm going to again work on this drawing itself. So I'm using a marker so it's easy to understand. Let me just put numbers here, letters here, A, B, and C. Now to bisect A and B, I put my pointed edge of my compass on B right here, take a radius more than half, and then swing the arch pretty much going all the way, just like that. Okay, then take the compass pointed edge on A and swing another arc pretty much going all the way till it intersects each other. Now when that is done, the next thing I would just have to do is just join intersection 1 to intersection 2. Okay, so what it already did, it bisected it, right? It bisected A and B. Now I would do the same thing to A and C. I would put my pointed edge on A, swing the arc going all the way. I could put it on C, swing the arc going all the way. And when I get this and that intersection, what would I do? Just draw a line going through both of them. So now A and C is bisected. Again, the same exact procedure with B and C. Put the pointed edge on B, and I would swing an arch going all the way like that. So if you see, all these arcs are pretty much falling on top of each other. Now again, the reason being, this is an equilateral triangle. I'll go on C, swing my arc, just going like that all the way till I get my 2 intersections, which is 1 and 2, and then just join a straight line. So this gives me, this is what I have done to bisect all the 3 legs of my triangle. Now let's go to the next one, where I have to construct a circle to 3 given points. So all I am given is 1, 2, and 3 given points. Now the first step that I would need to do is just join these 3 points with a line. Just like there, right there, and right here. So now what it gave me is A, B, and C. Now is this triangle that we got, is it the same as this one? No. This has all equal sides. So that's why this is an equilateral triangle. Now this one looks like it doesn't have even a single side that is the same size. So this is a scalene triangle, right? So to construct my circle, the next thing I would do is bisect A and B and A and C. I'm just going to bisect 2 of them using the same exact method that I used here. But again, you have to remember that this is a scalene and the one that we did before was an equilateral. For example, if I stretch that line, it would go straight through the center, right? Why? Because again, it's an equilateral triangle. But in this case, it is not. So let's draw my first arc, putting my compass pointed edge on B and drawing an arc that goes just like that, going all the way. I'm just taking it all the way. Okay, maybe I'll take a smaller pen so we don't get confused. Okay, so I'm gonna put it on B, pencil edge a little more than half, and then swing my arc going all the way like that. Okay, then I'll do the same thing, pointed edge on A, and I would swing my arc all the way up to here. Now the next step I need to do, like always, is just join the 2 intersections, which is 1 and 2. Now if you see the intersection is not going towards C. Why? Because it's a scalene triangle. Now I would do the same thing onto A and C. I would swing my arc, putting it on A, and swing my arc, putting it on C. The next thing I need to do is just connect the intersections with a straight line. Okay, there you go. Maybe that's a little off, so let's connect it again. So now what I got is the intersection point, which is right here, correct? Now with this intersection, would I be able to draw my circle? Yes. So the only thing I would need to do is put my compass right in the middle, adjust the pencil edge till one of these A, B, or C, and then I will have to do is from this center draw my circle, and it should touch all 3 A, B, and C. Okay, that's exactly the way it's done over here. Okay, now if you want to go over it again, I have 1, 2, and 3 points. All I did was swing some arcs, which is 1, which is 2, and once that was done, I took my marker and I joined 1 right? So the one is already done. Now to go to the next one, do the exact same thing. Swing one arc going all the way, and from this point swing another arc going all the way. Now if I would join it, with the line, it meets right there, and that is my intersection point, or that is the center of my circle that I'm going to draw now. To draw the circle, I take that as the center, and my radius is either this one, or that one. So putting the pointed edge here, the pencil edge here, here, or here, I can just turn it and finish up my exercise. Okay, so I hope you followed that tutorial. Again, it's a little different from this one, mainly because this is a scalene and this is an equilateral triangle. Now let's jump to the last one. Now the last one is this one. We've already done that. To do bisect an angle, which is a right angle in this case, I have A, B, and C. Put my compass on B, and I would swing an arc, continue, swing an arc. Same thing I would do is go to this intersection and this intersection, and this one and this one. Put my compass on here, swing an arc, put my compass on here, swing an arc, and that gives us our bisecting line. Okay, there you go. Now the way I did it over here is a little different, but don't worry about that, because what I did over here, we have the same distance, which is, this is 5 and 5. I just put right there, swing that, put it right here, swing that. So this is fine if the distances are equal, then you would still get the bisector, but you have to follow this method. Okay, now let's see what else do we have in this one. The last thing that we have in this one is just some basic tracing. So all you have to do is, half the object is already given to you, and you have to complete it by tracing it. So to trace this, first of all, what you need is a grid. Now half of this is already given. To do the other half, to make sure everything falls onto the grid. Now I don't have a grid on here, but you could use a grid paper, or you could draw your own grid. It's up to you. But again, this is just a practice exercise, right? And using this grid, we would count our squares and then place our object accordingly. Let me just do this example really quick, just by tracing it right here for you. Start from point here to here, because I counted if this is 1, this is 1 as well, right? And I go this way, which was whatever distance till there, and then I have to swing my arc till here. Swing the arc number 2, straight line, swing arc number 3, straight line, swing arc number 4, straight line, arc number 5, straight line, then another straight line, and arc number 6. So this completes our little tracing tutorial. But again, you would use this with a grid. Okay, now getting onto this is an ellipse. Again, we are working freehand, so I'm gonna go nice and easy, going and making our half of the ellipse. So that's 1, that's 2, and that's 3. See, that's 3, Not that easy. 3, 4, 5, 6. So that was 6 radius right there. And then this is the 7th one, which is for half the circle. And we have some straight lines, 1, 2, and 3. So that completes our tracing exercise. Now the next thing we would be doing is going to our next tutorial, which is a little bit more tougher than the ones you've done before, where we will be drawing all of these objects that you see on the screen. Okay, a lot of pentagons, a lot of arcs using the tangent method, and so that would be the next tutorial. Okay.